While we wait for the slides to appear, I'll try and make it work. I'm a tech lead here at Wehkamp. Been doing that for a couple of years now, and I'm going to talk a bit about how we're doing product onboarding, which has changed since we started back in 1950s. Has changed quite a bit. All right, a very cheesy one-liner to start off with. Delivery is where it ends, but you really need to start at onboarding. If you want to buy a new PlayStation, that's cool. But if we don't manage to get you all the details showing up on a product detail page, you're not going to be able to find it. You're not going to be able to browse for it. You're in no luck. You're not ultimately going to order it. So onboarding is key in what we're doing. And this is how we did it. Remember, 1950s, 1960s, 70s, 80s, internet was invented, and 1990s, Excel was invented. Yay. Great. So every piece of onboarding meant an Excel spreadsheet with a lot of rows in it, with a lot of columns in it, and this spreadsheet was pre-built, and it was very specific on the requirements per article. Every column had a very explicit name, and the spreadsheet was sent through pigeon or email to a supplier. The supplier would fill it in, it would come back, and voila, it would run through a system, provided Excel would not break, because, well, it's Excel. And it's, to make things worse, it's not just one spreadsheet, but it's multiple spreadsheets. Yeah, and if you start mixing multiple spreadsheets into one, things break. Simple as that. So onboarding was a very sluggish process until recently. It took, well, not literally, but it took quite long. It took ages before we could put a new product from inception to website. It just takes not just weeks, but it takes months. And that is insane because it's almost 2020. And we can do stuff real time. So let's do that. So this is what we used to do. We were very explicit. We want to have the color field on this specific dress and nothing more than just that, which is great because now on the website we can start selling a dress and we can tell our customers that it's a yellow dress. Brilliant. Excellent. Yeah, okay, so we also would like to know the size. So, dear supplier, please give us some information regarding size as well, because now we can sell the yellow dress in both large and small. Great, cool. Yeah, so you can see where this is going. It didn't make any sense. Well, it did at the time, but today we want to have more information than what we initially asked for. In fact, we just want to have everything. So instead of asking our suppliers to just give to pre-fill a piece of, well, a spreadsheet and just hand us those 10 columns that the spreadsheet contains, we flipped it, literally, and we're saying, well, just give us your feed. This feed contains all the fields that you can dream of regarding the specific products. And with that, we will have an abundance of information on this specific article. And we can cherry pick whatever we need on our end, but you, supplier, just give us everything. Because today we're interested in color, tomorrow we're going to be interested in, I don't know, gender. And the day after we're going to be interested in something that is maybe not even invented yet. So in order to remain flexible, we're just asking for everything. And this is where Databricks comes in. As Tom mentioned, we're a heavy user of Databricks, notebooks, and instead of doing stuff in Excel, which is brittle, which breaks, and yeah, it doesn't have an API, so it sucks. We're doing stuff in notebooks, which means quite literally, we're building Python scrapers that go log on to a supplier website, query for specific products, and just grab all the information that's there. Whether it be product information or product images, photographs, we just grab everything. Everything we can get our hands on. I mean, it's our login, so that's covered. We're not doing something out of line. but it's completely a different approach as compared to what we used to do, which was just asking them for very specific pieces of information. We're just grabbing it all. And doing that, we can now create new information from this information. We can train machine learning models to look at all these various attributes and come up with clusters. So we can do combinations, for example. And previously, we could not do that, provided there was the information was available. So by flipping it, we can also unlock a new potential. What we architected, what we built, apart from just the notebooks, because notebooks are great to get an initial kickstart, but ultimately you want to have some kind of a system or a platform that you can give to your business and that contains basically all the value, all the information. So we started building what we call the enrichment pipeline, which is basically built around 2 Kafka topics on our regular Kafka machines, on Amazon EC2, of course, and maybe 1 or 2 or 3 S3 buckets. And that's all there is to it. And we're storing all the assets that we receive, that we scrape by using our notebooks. We store them in this data lake, in the enrichment pipeline, and I'm going to show you an image on the next slide. The assets in themselves will be stored on S3, and the whole thing basically is event-driven after that. So the event kicks off that there is an image being uploaded, or a JSON file has been uploaded with product information, just an ordinary event. And ultimately, all the information ends up in Elasticsearch, which has a very nice HTTP API, so you can query it using just about anything, which at the time was a very, let's say, easy way to get started, to get going. So this is what it looks like. It's literally 2 microservices deployed on our regular platform. Those are .NET something something. And they're very simple, very straightforward. Receive a file, drop it on S3, put a message on your event bus, Kafka, and then you have a notebook, or 10 notebooks, or 100 notebooks that do the actual processing. So an image comes in, the message gets dropped that, hey, this image from I don't know what brand got uploaded, a processor notebook, because it's literally a notebook in there that's doing it. So it's not a service, it's not something very difficult, but it's really just a notebook that you can look at using your browser, that you can type in on the fly pretty much, and have adjustments be made, applied on the fly. But it's looking at messages that come in, downloads an image, for example, runs it through a machine learning cropping model, and it outputs a slightly changed version of the original image. And that ultimately ends up in Elasticsearch. And that's completely flipping it, because let's say last year, we actually had to do that manually. And if you run all these images manually through some kind of Photoshop thingy, it just takes ages. And this way we can do it in seconds, which is a lot easier. And the whole thing is streaming, so that means new information is uploaded and instantly being read and is executed upon. So that means when we upload information concerning an article, in real time we can also run it through a machine learning model that says, oh, this image is addressed, okay, I can tell that using my machine learning model. I can also say that it's read. And what we can then do is verify this piece of information that our machine learning model came up with, verify that against a product feed that we also get from the supplier. And the product feed would have the color of this dress set as black, whereas our machine learning model is like, yeah, whatever, it's yellow. So we can actually start doing a bit of QA on the information that we receive and that we have agreed upon with our suppliers to be correct. And now we can tell the supplier, hey, dude, come on, you're sending us rubbish. And we couldn't do that because we were too busy filling out all these spreadsheets. We were too busy hoping for the spreadsheets not to break. And this way we can just, it scales. And this notebook it's not one notebook, it's not two, but it's multiple notebooks, which makes it a lot easier to maintain, to build, as opposed to running it through regular services. It's also not needed. I mean, these notebooks just read from a topic, do some transformations, write to a different topic. That's all there is to it. And it's a streaming job within Databricks, runs every 30 minutes or so, and just looks at what's the offset that I left at, of the message that I processed last, and it'll pick up from there and do the processing. Doing it this way means we have a perfect view on all the stages that are images, but also regular assets like product information, JSON files. All the stages those files go through are made visible. Because every time something would happen, you would have a message on either the incoming topic or the import topic, or the export topic. And once you have all those events, you can just start tracking them, making them visual, and show to your business, well, this here is your process. And it's not the process that you had in mind, but looking at the data, this is what's going on. And doing it that way, you can, because after this whole, let's say, lake, the enrichment pipeline, that's just the beginning. It still takes a while before it's ultimately shown on the website. But if you can tell, well, I got images from Nike on the 1st of the month, and I can see that they show up on the website on the 1st of next month, and I have all my events from the enrichment pipeline in between, I can pinpoint where my congestion point is. Why is it taking so long? So machine learning models, we also have quite a bunch of those. And in the beginning, we had regular Keras models running inside Spark pipelines, worked fine until they didn't work. They started not working fine. So we looked at what do we want to do with those models, and we made a decision to go with TensorFlow serving, because what we were after was basically an HTTP endpoint that we can just query with, for example, an image, and that can return a prediction. And we started doing it in Spark. That blew up a little, considering the real time and considering the setup. So we changed that to TensorFlow serving. Yeah, that works. Brilliant, actually. So we have our models being deployed through regular software engineering processes, just a regular CI/CD, Jenkins, and all that stuff. We end up with an HTTP endpoint on our microservices platform, and this endpoint can be queried from our notebooks, because it's just Python. You just import requests.post, etc., and there you get it, a prediction on the image that you gave it. And this scales a lot easier, a lot better, because remember let's see if I can go.
Dus?
No. Thank you, Siri. So it scales, being that if you look at the notebook is sitting right in between incoming and enrichments. So if you have a new model, only thing you need to do is put in a new notebook with a new deployment of TensorFlow serving with that specific model, and done. That's it. All your newly added content will be run through this new notebook, which is very, very easy to do, powerful to do, because again, it's just a notebook.
And you run multiple notebooks at the same time?
We can run multiple notebooks at the same time. Yeah, yeah. Because the way it works is you have your notebook, which is in our case a bunch of Python code, which is it's pretty comparable to Jupyter notebooks, hence the title of the talk. and you launch a cluster within Databricks on EC2, and every notebook, every run, every job can have a dedicated cluster or its own cluster. So you can have multiple instances of a cluster, and you can have multiple notebooks running at the same time.
Because if you say it is event-driven, so somebody uploads a new image,
Yep.
for instance,
Yep.
you can then run multiple notebooks on
Yeah.
that image.
Because the event will be placed on. So the event is you're uploading an image. The image gets pushed to the S3 bucket using the import service. The event message is posted to Kafka, and this can just be consumed. And your notebook, that's probably it. The notebook is just an ordinary Kafka consumer, and that's how you do multiple notebooks to one topic. So, yeah, that was it. Thank you.